Welcome. Today we are looking at acids, bases, and salts at an advanced level. This is a key topic in your chemistry exams for SS3. Pay close attention. Let us begin. First, let me explain what acids are. An acid is a substance that produces hydrogen ions when dissolved in water. Acids have a sour taste. They turn blue litmus paper red. They react with bases to form salts and water. They react with metals to produce hydrogen gas. They react with carbonates to produce carbon dioxide gas. Acids are classified as strong or weak. Strong acids completely dissociate in water. They produce many hydrogen ions. Examples include hydrochloric acid, sulfuric acid, and nitric acid. Weak acids partially dissociate in water. They produce few hydrogen ions. Examples include ethanoic acid, citric acid, and carbonic acid. The strength of an acid depends on its degree of dissociation. A concentrated acid has a high amount of acid per volume. A dilute acid has a low amount of acid per volume. Concentration and strength are different. A dilute strong acid can be more acidic than a concentrated weak acid. Now, let me explain what bases are. A base is a substance that produces hydroxide ions when dissolved in water. Bases have a bitter taste. They turn red litmus paper blue. They react with acids to form salts and water. They feel slippery. Bases are classified as strong or weak. Strong bases completely dissociate in water. They produce many hydroxide ions. Examples include sodium hydroxide, potassium hydroxide, and calcium hydroxide. Weak bases partially dissociate in water. They produce few hydroxide ions. Examples include ammonia and ammonium hydroxide. The strength of a base depends on its degree of dissociation. A concentrated base has a high amount of base per volume. A dilute base has a low amount of base per volume. Alkalis are bases that are soluble in water. All alkalis are bases, but not all bases are alkalis. Now let me explain the pH scale. The pH scale measures the acidity or alkalinity of a solution. It ranges from 0 to 14. A pH of 7 is neutral. A pH below 7 is acidic. A pH above 7 is alkaline. The lower the pH, the more acidic the solution. The higher the pH, the more alkaline the solution. The pH scale is logarithmic. Each unit represents a 10-fold change in hydrogen ion concentration. pH is calculated using the formula pH equals negative log of hydrogen ion concentration. pOH is the negative log of hydroxide ion concentration. pH plus pOH equals 14 at 25 degrees Celsius. The pH scale is used to measure the acidity of solutions. It is used in many fields. It is used in medicine, agriculture, and environmental science. Now let me explain indicators. An indicator is a substance that changes color in acidic or alkaline conditions. Indicators are used to test the pH of a solution. Litmus is a common indicator. It turns red in acid and blue in alkali. Methyl orange turns red in acid and yellow in alkali. Phenolphthalein turns colorless in acid and pink in alkali. Universal indicator is a mixture of indicators. It gives a range of colors. It can be used to estimate the pH of a solution. Indicators are used in titrations to determine the endpoint. The choice of indicator depends on the type of titration. Now let me explain neutralization. Neutralization is the reaction between an acid and a base. It produces a salt and water. The hydrogen ions from the acid react with the hydroxide ions from the base. They form water. The cation from the base and the anion from the acid form the salt. For example, hydrochloric acid reacts with sodium hydroxide to form sodium chloride and water. The reaction is HCl plus NaOH equals NaCl plus H2O. Neutralization is an exothermic reaction. It releases heat. Neutralization is used in many applications. It is used to treat acid spills. It is used in the preparation of salts. It is used in antacids to neutralize stomach acid. Now, let me explain salts. A salt is a compound formed when the hydrogen ion of an acid is replaced by a metal ion or ammonium ion. Salts are ionic compounds. They are composed of cations and anions. Salts can be classified by their solubility. Some salts are soluble in water. Others are insoluble. The solubility of salts depends on the ions present. Most sodium, potassium, and ammonium salts are soluble. Most nitrates are soluble. Most chlorides are soluble, except silver chloride and lead chloride. Most sulfates are soluble, except barium sulfate, calcium sulfate, and lead sulfate. Most carbonates are insoluble, except sodium carbonate, potassium carbonate, and ammonium carbonate. Most hydroxides are insoluble, except sodium hydroxide, potassium hydroxide, and calcium hydroxide. The solubility rules are used to predict precipitation reactions. Now let me explain the preparation of salts. Salts can be prepared by several methods. The first method is neutralization. An acid reacts with a base to form a salt and water. This method is used to prepare soluble salts. For example, sodium chloride is prepared by neutralizing hydrochloric acid with sodium hydroxide. The second method is the reaction of an acid with a metal. An acid reacts with a metal to form a salt and hydrogen gas. For example, zinc reacts with sulfuric acid to form zinc sulfate and hydrogen. The third method is the reaction of an acid with a carbonate. An acid reacts with a carbonate to form a salt, carbon dioxide, and water. For example, calcium carbonate reacts with hydrochloric acid to form calcium chloride, carbon dioxide, and water. The fourth method is the reaction of two soluble salts. This is called double decomposition. It is used to prepare insoluble salts. For example, silver nitrate reacts with sodium chloride to form silver chloride and sodium nitrate. Silver chloride is insoluble. It precipitates out of solution. The fifth method is direct combination. Two elements react to form a salt. For example, sodium reacts with chlorine to form sodium chloride. Now let me explain hydrolysis. Hydrolysis is the reaction of a salt with water. It produces an acidic or basic solution. Salts of strong acids and strong bases do not hydrolyze. They produce neutral solutions. Salts of strong acids and weak bases hydrolyze. They produce acidic solutions. For example, ammonium chloride is a salt of a strong acid and a weak base. It hydrolyzes to produce an acidic solution. The reaction is NH4Cl plus H2O equals NH4OH plus HCl. Salts of weak acids and strong bases hydrolyze. They produce basic solutions. For example, sodium carbonate is a salt of a weak acid and a strong base. It hydrolyzes to produce a basic solution. The reaction is Na2CO3 plus H2O equals NaOH plus NHCO3. Salts of weak acids and weak bases hydrolyze. The pH depends on the relative strengths of the acid and base. Now let me explain buffer solutions. A buffer solution is a solution that resists changes in pH. It is a mixture of a weak acid and its salt, or a weak base and its salt. Buffer solutions are used to maintain a constant pH. They are important in biological systems. Blood is a buffer solution. It maintains a pH of about 7.4. Buffer solutions are used in laboratories. They are used in many industrial processes. The pH of a buffer solution can be calculated using the Henderson-Hasselbalch equation. The equation is pH equals pKa plus log of concentration of salt divided by concentration of acid. Buffer solutions are essential in many applications. Now let me explain acid-base titrations. An acid-base titration is a technique used to determine the concentration of an acid or base. A known concentration of one solution is added to a known volume of the other solution. The point at which the acid and base are completely neutralized is the equivalence point. An indicator is used to detect the equivalence point. The pH at the equivalence point depends on the strength of the acid and base. For a strong acid and strong base, the equivalence point is pH 7. For a strong acid and weak base, the equivalence point is below pH 7. For a weak acid and strong base, the equivalence point is above pH 7. Titrations are used in many fields. They are used in quality control and research. A common exam question asks you to distinguish between strong and weak acids. Here is a sample answer. Strong acids completely dissociate in water. They produce many hydrogen ions. Weak acids partially dissociate in water. They produce few hydrogen ions. Strong acids have lower pH values than weak acids of the same concentration. Strong acids are stronger electrolytes. Weak acids are weaker electrolytes. The strength of an acid depends on its degree of dissociation. Another exam question asks you to explain the preparation of salts. Here is your answer. Salts can be prepared by neutralization, reaction of an acid with a metal, reaction of an acid with a carbonate, double decomposition, and direct combination. Neutralization is used for soluble salts. Double decomposition is used for insoluble salts. The method depends on the solubility of the salt and the availability of reactants. Another exam question asks you to explain buffer solutions. Here is your answer. Buffer solutions resist changes in pH. They are mixtures of weak acids and their salts, or weak bases and their salts. They are used to maintain a constant pH. They are important in biological systems. Blood is a buffer solution. The pH of a buffer solution can be calculated using the Henderson-Hasselbalch equation. Buffer solutions are essential in many applications. Let me give you a quick summary. Acids produce hydrogen ions in water. Bases produce hydroxide ions in water. The pH scale measures acidity and alkalinity. Indicators change color in acidic or alkaline conditions. Neutralization is the reaction between an acid and a base. Salts are formed when the hydrogen ion of an acid is replaced by a metal ion. Salts can be prepared by several methods. Hydrolysis is the reaction of a salt with water. Buffer solutions resist changes in pH. Acid-base titrations are used to determine concentrations. Practice these concepts. When you have them down, move to topic 2.